Namaste. I, JV'n Swarnima, Assistant Professor in Jayati Vidyapeeth Women's University, Faculty of Education and Meteorology, Department of Science and Technology. So, in this session, we will discuss about the which we left in the previous session, numerical on the basis of our coplanar and collinear forces, basically system of forces. Okay, so let's start. The question says a triangle ABC has its sides AB equals to 40 meter along, positive x-axis, and side BC is equals to 30 along positive y-axis. Three forces of 40 Newton, 50 Newton, and 30 Newton act along the sides AB, BC, and CA, respectively. Determine magnitude of resultant of such a system of forces. So what we have to do, what we have to calculate here, we have to determine the magnitude of resultant force of this system of force. Okay, so let's start the solution. The system of we have this system which we have the 30 Newton force, 40 Newton force, and 50 Newton force. Okay, so firstly, in the triangle ABC is a right angle triangle because we have what we have the x-axis and y-axis. Okay, so we have a right angle in which AC is 50 Okay, therefore sine theta, what will be sine theta? 30 divided by 50, which is this 30 divided by this 50. Done, which is 0 0.6. Cos theta is 40 divided by this side 50, which is 0 0.8. Resolving all forces horizontally, that is along this AB. Okay, so sigma h will be 40 minus 30 cos theta. Why this 30 cos theta? I resolve this side, which create theta angle with this horizontal side. Then what we have to resolve, we have to resolve this theta into two components, which is x in the first one is in x-axis and second one is y-axis, which the first one which is in x-axis that will count as a cos theta, and which is in y-axis that will count as a sine theta. Okay, so what we are doing here, we are resolving all forces horizontally. So if we are saying horizontally, then we take the cos theta. Okay, so sigma h equals to 40. What is 40? 40 is this thing, which is already in horizontal, which is already in horizontal axis or x-axis. Okay, and 30 cos theta, which we resolve this theta. So 30 cos theta, what is the value of cos theta? We calculate here as 0 0.8. Put this cos theta value 0 0.8 here in this equation. Then after solving this equation, my sigma h will be 16 Newton. Now resolving all the forces vertically along BC, this BC. Okay, so what we are taking here in the vertical direction, this force is 50 Newton, we take it. Next, along this theta, I resolve it into two components, which is sine and cos. What is in the y direction is, or y direction or vertical direction is sine theta, then 50 minus 30 sine theta. Put the value of sine theta, which we calculate already here, which is 0 0.6. Put the value of sine theta as 0 0.6 in this equation. Then my after resolving this equation, my sigma v will be 32 Newton. Now I have sigma h, I have sigma v. What is the formula of resultant force, magnitude of resultant force formula? R equals to under root of sigma h square plus sigma v square. I have sigma h 16 Newton, I have sigma v 32 Newton, which we already calculated. Then my resultant force will be 16 ka square plus 32 square and under root of whole. Then answer of this after solution, my resultant force will be 35.8 Newton. Okay, I hope you understand that. Next is a system forces are acting at the corners. Okay, at the corners of rectangular block as shown in figure. So we have this 50 Newton, we have this 20 Newton, we have this 35 Newton, and we have this 25 Newton. This is a rectangular which sides are 4 meter and 3 meter. Determine, here we have to what? We have to determine magnitude and the direction of resultant forces, right? So firstly, what we are doing, we are resolving the forces along horizontal direction. So whenever we talk about the horizontally or whenever we talk about the vertically, that means we are calculating sigma h and sigma v. Okay, so sigma h will be, when we are talking about the sigma h, then sum with direction. Okay, sum with direction all the horizontal forces. When we talk about the vertical forces, resolving the forces along vertical direction or vertical forces, then what we have to do, we have to sum with direction all the vertical forces. Okay, so what is the mean of with direction sum? Let's understand it. Sigma h equals to 25. First, positive 25. Why positive? Because this goes in this direction. Okay. Next, minus 20. Why this minus 20? Because both forces having different directions. So one will be positive and other one will be negative. It is normal thing. So my 25 will be positive and my 20 will be negative. Okay, if we are more simplify it, then we take it as in the as a quadrant. We take x direction. This x direction is positive, this x direction is negative, this y direction is positive, and this y direction is negative. So take it as same like our quadrants, so which is simple for calculation. So sigma h equals to 25 minus 20 equals to 5. Now resolving the all forces vertically, then sigma v equals to what? This is 50, but goes in this which direction? In this direction. Then the sign will be negative. So minus 50 plus this 35 kilonewton is also going in which direction? In downward direction. Then the sign will be also negative. So minus 50 plus minus 35, this is the sum with direction. Okay, so minus 50 plus minus 35, the answer will be sigma v of minus 85. Now what we are doing in the for calculating or for determining the magnitude of resultant force, we are squaring my horizontal and vertical forces with under root of that sum. Okay, so R, what is my formula for this? R equals to under root of sigma h square plus sigma v square. What is my sigma h here? Sigma h is 5 kilonewton. What is my sigma v here? Sigma v is minus 85 kilonewton. So put these value in this equation. Then what will be my equation? My equation will be under root of 5 square plus under root of, sorry, plus minus ka 85 ka square and whole under root. Okay, so after solving this equation, my answer will be 85.15 kilonewton, which we have to calculate here. Now what we have to calculate also, we have to calculate the direction also. So if we are talk about the direction, then what we have to calculate here, we have to calculate the theta. If whenever we have to calculate the direction, determining any direction of any force system, then what we have to calculate, we have to calculate theta about that. So what is my formula of theta? Tan theta equals to sigma v upon sigma h. Okay, sigma v, what is sigma v? Minus ka 85. What is sigma h? 5. So sigma v upon sigma h equals to minus 85 upon 5. What will be the value? Value will be minus ka 17. Okay, if then tan theta value is minus 17, then theta value is tan inverse 7 minus 17. Then value after solving this inverse thing, theta will be 86.6 degree. Okay, so this is my answer for theta. Now since sigma h is positive and sigma v is negative, now here is a new thing. In the previous question, both values are what? Both values are positive. Now in this question, one value is positive and other value is negative, then what we have to do, we have to calculate according to that my theta. So resultant whatever the resultant force is lies on that section which we have the sigma h, yeah, that means my x direction will be positive, and sigma v, that means my y direction will be negative. So if I'm saying about the x direction positive and y direction is negative, then where we are standing at the fourth quadrant where the x is positive and y is negative. Okay, so my resultant force lies in between fourth quadrant, in between 270 degree to 30 degree, 360 degree, in between the 270 to 360. Then what we have to do, we have to calculate the actual angle of resultant force. How we calculate that? We have to subtract my theta with 360 degree. 360 minus 86.6, then my actual theta value will be 273.4 degree. So this is just some little twist of uh, questioning which we which is comes into in the examinations or in so many questions. Let's move to next question. The next question says the forces 20 newton, 30 newton, 40 newton, 50 newton and 60 newton are acting at one of angular points of a rectangular hexagonal towards the other five angular points taken in order. Find the magnitude and direction of resultant force. Then so I have this diagram which I have 20 newton, 30 newton, 40 newton, 50 newton and 60 newton. Okay, basically I have one of angular points of regular hexagon towards this other five angular points. So what we have to calculate here, we have to calculate the resultant force, magnitude and the direction. Okay, so firstly what we have to do, we have to calculate the horizontal force and we have to calculate the vertical force. For the horizontal force, firstly we have to calculate we have to resolve these forces, we have to calculate these forces, we have to resolve these forces into two components, which is sine theta and cos theta, just because of these forces are at an angle with the horizontal. So let's start it. And one more thing, in this question all the angles are not with horizontal, so we have to make it with horizontal. How we make it? For C, for 30 newton it will be 30 as usual. For D it will be 60. How 60? 30 plus 30. For E it will be 90. How? 30 plus 30 plus 30. Okay. For F it will be 120. How? 30 plus 30 plus 30 plus 30. Okay, so now we are resolving these components in resolving these forces into two components, which is cos theta and sin theta. We are taking for horizontally for horizontal direction we are taking cos theta. For vertical direction we will take sin theta. Okay, so sigma h equals to 20 cos 0. Why cos 0? Because there is no angle between between this force and the horizontal direction. So that angle we count as 0. Okay. For C, it will be 30 Newton cos 30 degree. Okay. 30 Newton multiply by cos 30 degree. For this 40 Newton multiply by cos 60. For 50 Newton multiply by cos 90. For 60 Newton multiply by 120. Okay, so 20 cos theta cos 0 degree plus 30 cos 0 30 degree plus 40 cos 60 degree plus 50 cos 90 degree plus 60 cos 120 degree. Why we are multiplying this newtons in with this cos theta? Because whenever we resolve the force, we are taking the force intensity or that force magnitude with along with this resolving components. Okay, so that's why we are saying 30 cos theta, 20 cos 0, 40 cos 60. Okay, the value of cos 0, cos 30 and cos 60, cos 90 and cos 120 we put in this equation. Then after solution my sigma h will be 36 Newton. Now resolving all these forces vertically, then sigma v equals to 20 sine theta, sine 0, sine 0, that means because uh, there is no angle between this vertical and this force, the vertical direction in the force. Okay, so 20 sine 0 degree plus 30 sine 30 degree plus 40 sine 60 degree plus 50 sine 90 degree plus 60 sine 120 degree. Put the value of sine 0, sine 30, sine 60, sine 90, sine 120 in this equation, then my sigma v will be 151.6 Newton. Now, what we have to do, we have to calculate magnitude of resultant forces. How we calculate that? We calculate that by R equals to sigma h square plus sigma v square, which is our formula. So sigma h, what we calculate the sigma h value and sigma v value, 36 Newton and 151.6 Newton. Put these value into this equation, then my resultant will be 155.8 Newton, which is our first answer. Now what we have to calculate, we have to calculate the direction also. So whenever we calculate the direction, we talk about the theta. So tan theta will be sigma v upon sigma h. Sigma v will be 151.6 and sigma h is 36. Dividing these both values, then my tan theta will be 4.211. Now what is my theta? Theta will be tan inverse 4.211. After solving this 4.211, my value will be 76.6 degree, which is the second answer. In this equation, my sigma h and sigma v both are positive. That's why my answer will be in positive section, which is in my first quadrant section. So if my theta is 76.6 degree, that means it is the actual theta, or it is the actual direction of my resultant force. Next question says the following forces act at a point: 20 Newton inclined at 30 degree towards north of east, 20 Newton towards north, 30 Newton 25 Newton towards north, 30 Newton towards northwest, and 35 Newton inclined at 40 degree towards south of west. Find magnitude and direction of resultant forces. Now, what we have? We have one force which is 20 Newton at 30 degree towards north of east. Okay, 25 Newton in north, 30 Newton in northwest, 35 inclined at 40 towards south to west, south of west. Okay, so these all are my forces. Now again, what we have to calculate, we have to calculate the horizontal force and the vertical force. For horizontal force, we have to resolve these two 20 Newton and 35 Newton forces into two components, which is sine theta and cos theta according to their theta. So let's start. 20 cos 30 plus 25 cos 90, done, plus 30 cos 135 plus 30 cos 220 Newton, which is my after components resolution values of these forces. So sigma h, after putting the value of cos 30, cos 90, cos 135 and cos 220, my value will be minus 30.7 Newton. For sigma v, my value will be calculated as sine, all the value of sine theta. So 20 sine 30, 25 plus 25 sine 90 plus 30 sine 135 degree plus 35 sine 220 degree. After the putting the value of sine 30, sine 20, 90, sine 135 and sine 220, my value will be 33.7. So here what we have to calculate, we have to calculate the magnitude of resultant force. Okay, so what is the resultant force formula? Under root of sigma h square plus sigma v square. Sigma h value is minus 30.7. Sigma v value is 33.7. After solving this equation, my value will be 45.6 Newton. Now, again, we have to calculate what? We have to calculate theta. That means my direction of resultant force. Here, one more thing, which is sigma h value. That means my horizontal force will be minus 30.7. That is minus 30 points. Minus 30.7. Okay. So, minus 30.7 and sigma v will be 33.7. That means 33.7. That is why my vertical force is positive, my horizontal force is negative. So in which quadrant it lies? It lies on second quadrant. Okay, where my x values are negative and my y values are positive. Done. So what is my theta value? Theta's formula: tan theta equals to sigma v upon sigma h. Sigma v equals to 33.3, 33.7, and sigma h equals to minus 30.7. My value will be tan theta is 1 minus 1.098. After solving this, tan theta is again theta equals to tan inverse minus 1.098, and theta will be 47.7 degree. Now the value is 47.7, which is in first quadrant, but my sigma h and sigma v is in second quadrant, is like second quadrant values, because my sigma h is negative and my sigma v is positive. So what we have to do, we have what we understand about this, according to this, that my value of theta is not correct according to my sigma v, according to my sigma h. My value will be lies on the second quadrant, which is from 90 to 180. Okay, so what we have to do here, we have to subtract this value of theta by 180 degree. So after subtracting, the value will be 132.3 degree, which is my actual angle of my resultant force. I hope you understand about this question. Next question is, a horizontal line PQRS is 12-meter long, where PQ equals to QR equals to RS equals to 4 meter. Forces of 100,000 Newton, 1500 Newton, 1000 Newton, and 500 Newton act at PQRS respectively. With downward direction, the lines of action of these forces make an angle of 90 degree, 60 degree, 45 degree, and 30 degree respectively. With PS, find the magnitude and direction and the position of resultant forces. So what we have here, we have this horizontal line. First, we have this horizontal line PQRS. There are some points. The horizontal line is 12-meter long. We here also give what we the value of PQ, the value of QR, the value of RS is 4 meter. Okay, there are some forces at these point, which is 1000 Newton, 1500 Newton, 1000 Newton, and 500 Newton. The angle which these forces are make with this horizontal line is 90 degree, is 60 degree, is 45 degree, and 30 degree. Now again we have to calculate what? We have to calculate the magnitude of resultant force. For the magnitude of resultant force, we have to calculate sigma h and sigma v. How we calculate the sigma h? We resolve these thetas with in two components, which is sine theta and which is cos theta. Okay, so 1000 cos 90, 1500 cos 60, 1000 cos 45, and 500 cos 30. Put the value of cos 90, cos 60, cos 45, and cos 30 in this equation. Then after solving this equation, my sigma h will be 1890 Newton. Next, we have to resolve the all the forces by vertical direction. So in by vertically, we take all sine values in this equation. So 1000 sine 90, 1500 cos 60, 1000 cos 45, and 500 cos 30. Put the value of sine 90, sine 60, sine 45, sine 30 in this equation. Then my sigma b will be 3256 Newton. Now, what is my formula of magnitude of resultant forces? My formula is R equals to sigma under root of sigma h square plus sigma v square. Put the value of sigma h and sigma v in this equation. Then my formula value will be 3765 Newton, which is my first answer. Second, I have to calculate the direction. Now, whenever we talk about the direction, we quickly we have it is normal that it click that, but whenever we talk about the direction, we have to calculate what? We have to calculate theta. So the formula of theta is tan theta equals to sigma v upon sigma h. Sigma v is 3256, sigma h is 1890. Dividing these values, then my tan theta will be 1.722. Then theta will be tan inverse 1.722. Then my value of theta will be 59.8, which is my second answer. Now, what we have to calculate, the next thing, position of the resultant force. We have to calculate what? We have to calculate position. So let x equals to distance between P and the line of action of resultant force. Okay, so let's equate 3256, which is our sigma h. Okay, sorry, sigma v multiplied by x distance, 100 multiplied by 0 plus 1500 multiplied by 0.866, which is our cos value, sorry, which is our sine value. We are taking the vertical direction. So 100 multiplied by 0, 1500 multiplied by 0.866, multiply by 4 plus 1000 multiply by 0.707 multiply by 8 plus 500 multiply by 0.5 multiply by 12. So after solving this equation, my value will be 13852 equals to 3256x. Now how put the 3256x in the downward direction, in the downward of 313852, then x will be 13852 divided by 3256. My value of x, my value of this resultant position is 4.25 meter. I hope you understand about these equations and these formulas and these type of numerical very well. But if you have any problem, then please mention in a comment box. I'll resolve it. This session is powered by Digital Version 2.0 Vidyapeeth Women's University. Thank you very much.